Hello everyone, today we'll speak about ArgoCD. Again, in the previous video I told you about different concepts of ArgoCD. It is applications, application sets, apps of apps and generators. So if you're not familiar with ArgoCD, I recommend you to watch my previous video. And there is another previous video where we installed monitoring system in our clusters. And in this video I say that the way how we handle workload in our cluster is not the most efficient way. So why I say this? If you have 5 or 10 clusters, it's okay. You can manage all your workloads with Helm and GitLab CI pipelines, and there will not be a problem. But if you have maybe 30, 50, hundreds clusters, there will be a problem. Because in this situation, you will need to create very flexible, efficient GitLab CI pipeline which will deploy all these services among a lot of your clusters, among hundreds or thousands of clusters. And that's not so easy. You will need to create maybe different generators for your GitLab CI pipelines so that your code will not repeat itself. And yes, that's a problem because it takes a lot of time. But so that's the reason why I create this video. And I will show you a sample ArgoCD project, maybe template, call it as you want. This template show you all aspects of ArgoCD. There are applications, application sets, apps of apps, and also generators. This template is responsible for deploying monitoring system among a lot of clusters. In a nutshell, with this template, you can deploy monitoring system among a lot of clusters. It doesn't matter how many of them do you have, with only one command. Just type kubectl apply and that's it. Like ready to go template. So let's move to the diagram of the project structure and of the logic of this project. So as we can see here, we have 3 clusters. It is service cluster, development and production cluster. And remember that it doesn't matter how many clusters do you have. So first of all, we need to define which services in which cluster will be deployed. So we have Grafana. Grafana will be deployed in the central cluster, in the service cluster. We don't need a lot of instances of Grafana among different clusters. We just need one central Grafana where we will search for logs, metrics, and other things. So Grafana will be deployed in service cluster. Same with Locky, because Locky will get logs from Promtail. Mimir also in service cluster, because Mimir will get metrics from Prometheus. Also, Alert Manager will be deployed in central cluster, because all alerts from different clusters in our infrastructure will be federated to central alert manager, where we can easily manage different roles and other things. And of course, we will deploy Promtail and Prometheus in service cluster because we need to monitor service cluster too. So, and another clusters, for example, development and production cluster, in these clusters will be deployed Promtail and Prometheus to scrape metrics and logs from pods. Alerts from this Prometheus will be federated to central alert manager, and metrics from Prometheus will be sent to Mimir, and logs from Promtail will be sent to Locky. Nice. And we will connect Locky and Mimir as data source for Grafana. So let's move to the logic of ArgoCD deployment. So we have GitLab private repository and we have root application.yaml. So this is an example of apps of apps. So this app will deploy other entities. It will deploy applications and application sets. So let's start with applications. You need to remember that each ArgoCD application must map to one logical service. So one-to-one logic. You need dedicated application for each dedicated service. So I think that's clear. So for example, first application will deploy Grafana, another application will deploy Locky, and another application will deploy Mimir in our info cluster. And there are an application sets. Application set automates deploying multiple instances, for example, environments, clusters of the same logical service. So there is a logic one-to-many. According to this logic, we will create application set that will deploy Prometheus to each cluster using cluster generator, and another application set that will deploy Promtail to each cluster using application set. We don't need to kubectl apply all this application in the separate way. We just need to define regular expressions, so the root application will find these YAML files and apply them. So I think that's clear. Let's move to our repository. Finally, there is a repository where these templates are stored. So first of all, let's start with ArgoCD values. As we can see, first of all, we need to define our config. We need to connect clusters to ArgoCD instance. Just replace these values with your data and you will be good. So also pay attention to naming of your clusters. You can name it as you want, it doesn't matter. Later we need to connect our repositories. I think that your repo will be private. You just need to paste URL for your repository and authentication credentials. In my case, I will use GitLab. So we need to go to the project settings, to the access token, so ArgoCD, select role developer, and here we need read and write repository. Create project access token, just copy it and use it here. And that's it. When we install ArgoCD, this repository will be already in our instance, same as these clusters. Maybe you'll need to configure your LDAP authentication for your enterprise, but if you don't want to use LDAP, just comment this rows and you'll be okay. Resource-based access control, so if you want to use them with LDAP, you just need set it to true, create default policy for registered users, and define custom policy. For example, if you have LDAP group, my DevOps team, members of this LDAP group will be admins in ArgoCD instance. So DEX, it is for LDAP authentication. If you don't use LDAP, you can disable it. For example, if you deploy ArgoCD in the private network, you will not have access to the intranet. Maybe you will want to use your private Docker proxy. So just uncomment these lines and replace this domain with your Docker proxy. And there is a ingress settings. I think it's clear. If you want to deploy ArgoCD in high availability mode, you need to increase controller server, repo server, and application set replicas to 3. Also, you can find values for Redis high availability cluster, but I don't use it here. So that's it. With these values, you can easily install your ArgoCD instance. You can find this ArgoCD Helm chart on Artifact Hub and search for default values and installation options. There is an Argo Apps folder which contains application sets, applications, and apps of apps folder. First of all, we remember that we have root application. So this application name is monitoring. And here we define repo URL, where this application will find YAML files. We will use directory recursive mode and include all YAML files from applications folder and application sets folder, and exclude apps of apps. This application will be deployed to central cluster where ArgoCD is installed. So according to this logic, this application will apply all applications that are stored in applications folder and application sets folder. So let's move to the application sets. Here we have a lot of different folders. It is Prometheus. As we can see, there is an application set which use cluster generators. This will generate an application for each cluster in your ArgoCD instance. It will use cluster name in the name of this application. It will deploy to the monitoring project. So as we can see here, we get value files from the same directory. Here, values base.yaml, there is values for Prometheus. and this application set get values from this folder and apply them. But also here we have an override. It is very useful because you need to define from which cluster different metrics come based on the external labels. And here we just override default values from chart with our values from this directory and overwrite these values with these values. So it's very useful because you can use ArgoCD generators for generating Helm values. As a result, we will have metrics that come from maybe development cluster with external label cluster development. And it's very useful. You don't need to create dedicated values file for each cluster. And this application set will do all work for you. Next, we have Prometheus CRDs. The problem that this Prometheus Helm chart do not install different CRDs for Kubernetes clusters like Service Monitor and other things. So we need to install them manually. So we use Prometheus operator CRDs, Helm chart, using application set, install it in each cluster. Here we have Prometheus rules folder. This application set is creating Prometheus rules for each cluster. This application set search for YAML files in this repo, in this folder, and we define all these Prometheus rules here. So as we can see, we just define config map with Prometheus alert rules, and after we create a new YAML file, for example, new alert.yaml, just paste something here, maybe new rules or something else, save, commit, and this new rule will be appear in your Prometheus. So it's very useful, because you manage your workload only with Git without any pipelines or something else. When we create these rules, we need to mount these new config maps to our Prometheus deployment. So we mount it here in Helm values. As we can see, mounted this config map, for example, Kubernetes rules, and we mount it here. And after this, new rule will appear in your Prometheus deployment. Same with Prometheus additional scrape configs. So I will show you Prometheus scrape configs. It is like Prometheus rules, do the same thing, but for scrape configs. So it search for YAML files in Prometheus scrape configs. You just create new scrape config, for example, create new config map in this folder and attach it here, and here we go. Next, PromTail. Based on the previous examples, I think it's clear how PromTail application set works, the same way how Prometheus application set works. So here we have PromTail Helm chart from Grafana, which deployed in each cluster with a custom name and with override values like external labels cluster, as we do it in Prometheus. Next, applications. Here we have Central Alert Manager. There is a sync wave to deploy Central Alert Manager after Mimir, but before Grafana, it uses Alert Manager Helm chart and values from this folder, so we can see it here. There is a default Alert Manager values with a custom Telegram Markdown template. Maybe it will be useful for you with the mounted secrets. So there is Grafana application. As we can see, nothing special. Get values from this folder using official Helm chart from Grafana. So there is a default values, nothing special, nothing. But dashboard providers is necessary for us, because by this way we will be able to define new dashboards using config maps. And by these sidecars, we also can configure Grafana to get dashboards from config maps. Same for data sources. I will show you how it works. Here we have next folder, Grafana resources. This application deploy different YAML files from Grafana resources folder So as we can see here, Grafana resources, there is a dashboards and data sources folder. So dashboards, we just need to create new YAML file with a config map of our dashboard. And this dashboard will spawn in Grafana UI. Same with data sources, just paste new data source here, and here we go. So I think it's clear. So as we can see, we can manage our workload only using Git. For example, you need to add new dashboard, just commit to Git. You need to add new data source, just commit to Git. You need to create new alert rule, just commit to Git. You need to create new script config, just commit to Git. I think that's very useful. Lucky, nothing special, same things as I said before. Lucky, deployed in the central cluster where ArgoCD is deployed. Get values from this folder, and that's all. In Lucky, we use simple scalable mode. We mount extra environment variables from secrets like lock history credentials. It is S3 access key and S3 secret key. So here we have lock history secret. Just define here your values, apply it to your Kubernetes cluster, and that's all. Nothing special here. Next application is Mimir. Nothing special. Get values from this folder, deploy in ArgoCD cluster. That's all. Also use extra environment variables from secrets for S3 access key and secret key. These values are wrong. You need to increase distributor, query, ruler, store gateway, and compactor to replicas. Other way, Mimir will not be able to get metrics from Prometheus, and you will not be able to add Mimir as data source to Grafana. There will be an error that you need to have minimum 2 replicas of ingester or distributor, I do not remember. And here is apps of apps, which I already described. If you do not understand something, there is a docs section where you can find all what you want. All things are described in efficient way. In my opinion, it is a very good example for education. This project involves application sets, apps of apps, so you can feel free to use it in your environment. So that's it. I will repeat in a nutshell. This root application will try to find different YAML files in this folder, in this repository, in the branch named main, including these path options and excluding itself. So to install this project in your environment, you just need to kubectl apply this root app in the cluster where ArgoCD are installed. After this application will create all these applications: Central Alert Manager, Grafana dashboards, data sources, config maps, Loki, Mimir. It will create Prometheus application set, Prometheus CRDs, rules, script configs. It will deploy Promtail, and these application sets will deploy each service in each cluster, and this application will deploy these services in the central cluster. So feel free to comment this video. Maybe I helped you and you learned something new. Thank you for your attention. That's all.